Hi there. On this page, we are asked to solve the following systems. The first one is x squared plus y squared equals 1, which is a circle, and then y equals x radical 3, which would be a line. So a circle intersecting a line, could happen in 0, 1, or 2 places. Let's go see what happens. This one's hopefully set up for a pretty clear substitution, right? Y equals x rad 3 can be easily substituted into the top equation, yielding x squared plus y squared equals to 1, and y is given as x radical 3. So therefore we would get x squared plus, 3x squared equals to 1. In other words, 4x squared equals to 1, and x squared is equal to 1/4. So once x squared is equal to 1/4, that means by taking the square root, x equals 1/2 or negative 1/2. So x can be either 1/2 or negative 1/2. By back substituting into the bottom equation, we can then see that if x were equal to 1/2, y would be radical 3 over 2. And if x were equal to negative 1/2, y would become negative radical 3 over 2. So it appears that the two solutions to this problem are 1/2, comma, radical 3 over 2, and negative 1/2, comma, negative rad 3 over 2. Hopefully, if you've been doing your pre-calculus well, you may notice those points from somewhere special. Okay, for the other problem, we have this system of 3 equations with 3 unknowns. And I think that this one on the bottom will be easiest for me to work with thanks to the zero product property, right? I have 3 numbers that have to multiply to 0, so that means either x equals 0, or y equals 0, or z equals 0. So let's use red to go through this first case, where if x were equal to 0, then substituting into the first equation would yield 2 times 0 plus y equals 5. In other words, y is equal to 5. And substituting into the second equation would yield 5 times z minus 0 is equal to 2. In other words, 5z equals 2, and z equals 2/5. So that, of course, would yield the solution of 0 for the x, 5 for the y, 2/5 for the z. Next, let's do the y equals 0 case. If y were equal to 0, then substituting into the top equation would yield 2x plus y equals 5. So 2x would be equal to 5, and x would be equal to 5/2. And then in the second equation, 5z minus x would be equal to 2. And as we solved up here, we can see that x was equal to 5 over 2. So now adding 5/2 to both sides, what's that going to give us? 5z equals, 2 plus 2.5 is 4.5. So that's a 9/2, right? Divide by 5 and divide by 5, and it looks like z is going to be equal to 9/10. So our coordinates coming from here would be x equals 5/2, y equals 0, and z equals 9/10. Finally, in that last case, we're getting z equals 0, so substituting into the second equation would give me 5 times 0 minus x equals 2, negative x equals 2, and x equals opposite of 2. And then going back to the top equation, we get 2 times x plus y equals 5. But as we just noticed here, we get that x is negative 2. So negative 4 plus y equals 5, and thus y must be 9. So the solution we're getting from here would be x is negative 2, y is 9, and finally z is 0.